Lovely. Keep reading. Next, soaps and detergents. So this is another important concept in this chapter. So actually, this is the last concept. So if you see that in the last yesterday's class and before class, we have studied what is the physical and chemical properties of ethanol, or we used to say ethyl alcohol, and the same way ethanoic acid. So ethanoic acid also we can call it as a what? Everybody? Acetic acid. So if you have noticed here, acetic acid and ethyl alcohol, you need to learn three things. One is what is the physical properties, and next one is what is the chemical properties, and the next one is what is the uses of them. So anything they can ask in the exam. Even yesterday we have discussed that present year sample paper. So in that additional practice paper, we have seen that how the questions they will ask it. So now let us come to the next concept, that is what soaps and detergents. So if you have noticed it here, soaps and detergents which we are using in our daily life. So soap also we are using for our purpose, and detergents we are using to clean our cloth, dirty cloths and all. So you can see, if you wash our dirty hands with the water alone, so what will happen? Suppose I am playing outside or I have done some work. So my body surface and everything will become dirty. So if I try to wash with my hands only with the water, so what will happen? It will only like what you can say completely it will not get clean. So that is why if I use some kind of a shampoo or a soap, or if I use a detergent powder, then my hands will be completely like it is even easy to wash. If you see, for example, oil surface. I have worked with like mechanic work, repairing the car or puncture. You can see definitely there is a grease and all, much oil will be stick to my hands. So if I would try to wash with my hands with the water, it is not possible to make it. So, but if I use it detergents, or if I use some kind of hand wash and all, easily I can make it. So any substance which is having a cleansing action means removing the dirt from our body or from our cloth. That is what we used to call it as a detergent. So write it everybody. Any substance, any substance, any substance which has cleansing, cleansing means cleaning only, cleansing action in water is called detergents. So now if you have noticed it here, so the any substance which remove dirt, if you want to say, which removes, in our local language if you want to say, which removes dirt, that is what we used to call it as a detergents. So now these detergents, if you have noticed it, there are actually two types. So whatever it is, to clean your hands or to clean your body or to clean your cloth or to clean your home, whatever it is. So all these substances in scientific language, if you want to say, like which will remove the dirt from the surfaces. So that is the reason any surface, body surface or hand surface or cloth surface, that is why the cleansing agents, whatever you are using maybe Dettol or you are using maybe Lysol or whatever the chemicals you are using, which is used to help us to clean the surfaces. That is what we used to call it as a surfactants. So note it everybody. So The soaps and detergents both are together, actually we are using as a cleansing agents, and they will work on the surface. Either it is a body surface or it is a floor or whatever it is. So that is what we used to call it as a surfactants. So we use soaps and detergents for many purposes in our daily life. So these detergents are two types. So detergents, if you have taken, there are actually two types. One is soapy detergents. Another one is non-soapy detergents. So if you see here, soapy detergents in our daily life, our daily language, if you want to call it as, that is only call it as a soaps. And non-soapy detergents, which we used to call it as basically synthetic detergents, or you can say simply detergents. Do you all understand, everybody? All the soaps and detergents, we used to call it as a detergents only. So which are soapy in structure, soapy to feel, that is what we used to say soaps. Which are non-soapy, which is SOAPY, non-soapy in nature, which is call it as a synthetic detergents, or we can say detergents. Okay. So now let us discuss one by one in detail. Let us start with the soaps now. So remember, every point is very important. Whatever the point will come out, you just note it and you learn it. So let us write now. If you have go to the chapter 2, acid, bases and salts, you might be remember. So acid, bases and salts, we discuss about soaps. So can you tell me what soap is a what, everybody? Is acid or base or what is that? Anybody?
Base.
Soaps is a what, everybody? It is the basic salt. Understanding? So yesterday also you might be studied saponification reaction. Am I right, everyone? Yesterday we studied the saponification reaction. Is it correct? And in that we studied a definition of soaps. Exact the page also came. So what is the definition of soaps you studied here? Soaps are, what the soaps are, everybody? Soaps are sodium potassium salts of long chain carboxylic acid. Long chain carboxylic acid. So they are what actually? Basic salts are acidic salts are. What they are, everybody? They are basic salts. Understand? So, can you guess why they are basic salts? Anybody? All of you? So, what is the reason? Why the soaps are made alkaline? That is the question. So, if you have seen here, because generally the dirt which is released by our body is actually acidic in nature. So as we know, the dirt what is coming, the dirt which is actually acidic in nature, so means in the sense of the soap must be in a what nature, everybody? The soap must be in a what nature, all of you? Alkaline in nature. So that what will happen? Acid plus base will react. So that what will happen, everybody? Some reaction will take place. What is that reaction we used to say, all of you? Neutralization reaction. So the dirt which is releasing by our body will be in acidic nature, and that is the reason the soaps are manufactured alkaline, so that the neutralize this acidic dirt, understand, by emulsifying it. So this is the word you are using in biology also. You remember emulsifying fats. Do you all remember, everybody? So the same thing will happen here. By emulsifying it, the soap will neutralize the acidic dirt. That is the reason the soaps are manufactured with a basic salts. Are you clear, everybody? So now, from this we can make a definition for soap, a cleansing properties. That is what, write it, everybody. The soaps is a sodium or potassium salts of, a soaps is a, the soap is a sodium or potassium, sodium or potassium salts of higher fatty. That is the reason I use the word fats are coming. Fats means immediately you have to use some word. What is that word? Biology also will get it. That is a word we are using, call it as emulsifying. Okay. So long chain carboxylic acids, only we can say higher fatty acids, which has cleansing properties in water. So that is the meaning of soaps. So now if you have seen here, so if you observe very carefully, so what is the soaps and how it will be happening and all. So there is a even activity for you. So about that, we'll start with that activity and then only we can go with that. Okay. So first, let us understand what is this soaps, and then we'll proceed what soaps contains and what is exactly. Now they are saying it exactly. You can take it. Activity 4.10. As I said you from here, activities also I will discuss and we will proceed according to that. So now if you see here, all of you, take about 10 ml of water in each in 2 test tubes. So how many test tubes we have to take it, everybody? All of you? 2 test tubes we have to take it. The results also I will say. So the thing is, when you go to lab, you can practice it. Okay. So now let us see. If you observe very carefully, so what they are exactly saying. So take about about 10 ml of water each in 2 test tubes. So you have to take it 2 test tubes. In each test tube, how much amount of water? All of you? 10 ml of water. Okay? All of you. So remember that. Now, add a drop of oil, cooking oil, to both the test tubes and label them as A and B. So I added 1 drop of cooking oil, and I labeled as this is A and this is B. Next, to test tube B, add a few drops of soap solution. Okay. So after that we have to add it what? Test tube B. I added how much? What I have added? Everybody. I added soap solution. Now shake both the test tubes vigorously for the same period of time. After that, you just started shaking it so that you'll definitely notice some change. That is what they are asking. Now, can you see the oil and water layers separately in both the test tubes immediately after you stop shaking them? They are asking. So let us see that. Now, leave the test tubes undisturbed for some time and observe, does the oil layer separate out? In which test tube does this happen first? Anybody can tell? What is your observation? Anybody? All of you? So if you notice it here, I will make the conclusions. Observe. So can we see the oil and water layer separately in both the test tubes immediately after you stop shaking them? First observation. Remember, that test tube, in which test tube we added soap solution, guys? You tell me, in which test tube we added soap solution? All of you? Please respond. In which test tube we added soap solution? I'm asking you. Is there anybody in the class?
Test tube B,
Test
sir.
tube B, sir. So test tube B, we added the soap solution. So what will happen, guys? The oil will dissolve. Please write. When oil and soap solution are shaken, so oil get dissolved in soap solution. Understanding? In soap solution means both get dissolved each other and they will form a single system or a single layer. Okay. So entire thing, each other, and they will form a single system or a single layer. Okay. Now, if oil and water is shaken, then if you left it for some time, then we find there are two separate layers of oil and water. So we notice two separate layers of oil and water. So here there is no mixing will takes place, but here the mixing will takes place so that it will turn up into single layer. But here two different layers we can notice it. So then that is what will happen if you have been left it. Then what is the conclusions from this? That is only is our concept. So oil cannot be dissolved in water alone. So if you have taken just, if you add the oil to the water, if you shake 1 hour also, oil cannot be dissolved with the water. Do you all understand, everybody? But if you add, because oil cannot be clean the stains of the, like we can say water alone cannot clean the stains of oil because they both cannot dissolve each other. But if you see, oil can be dissolved in the soap solution. So the soap solution can clean the oil stains. So that is why here only single layer will form because oil can completely dissolve in soap solution, but here oil cannot dissolve in water. So we'll notice it two separate layers here, but here as a single layer we can notice. So that is what is the difference between cleaning with the normal water, cleaning with the soap. So I hope you all clear. So that is what is the activity 4.10. Now this activity demonstrates what is exactly they are saying, you can see. So this activity demonstrates the effect of soap in cleaning. Most dirt is oily in nature. Very important. Note it. That's what I said. Oily in nature, as you know. Oil does not dissolve in water. So the molecules of soaps are basically what? Just now we studied. What is molecules of soaps? Soap is a what, everyone? Soaps are what, guys? Sodium or potassium salts of which acids? Long chain carboxylic acid, which is call it as a, we used to call something. Anybody is there in the meeting? That is what we used to call it as fatty acids. So the fatty acids which are used to prepare the soaps basically, and actual as we are using, like the soaps are prepared, whatever the soaps you have been taken, the soaps we are using the acids like stearic acid, preparation of soaps. We are using a oleic acid, all are fats, saturated fats, or we are using palmitic acid. So these are the acids, carboxylic acid, long chain carboxylic acids or fatty acids, which we are using to manufacture the soaps. So the ionic, what is the end of ionic and all I will discuss with you. So chemically the soaps actually they are, like you can see, they are the sodium and potassium salts of carboxylic acid. So the soaps what we are using in our daily life is the sodium stearate or sodium oleate, or we will say sodium palmitate. So these are the names of the soaps what we are using. A Santur, Lux, that Mysore Sandal, that is not is the names of the, that is a brand. So this is the exact name of the soaps, which is what we are using in our daily life. So the soaps can be represented by, the structure of the soaps can be represented by R, COONA, write it. This is the general representation of soaps. And R indicate here, R indicating alkyl group. Write it, everyone. Alkyl group whose carbon number varies from a group having carbon from 15 to 17. Very, very important point. So carbon number varies from where to where, everybody? 15 to 17. Understand, Amma? So that is what is the general structure of soap. Now we'll study that one and then we'll come back here so that you all will understand. So basically soaps, the number of carbons varies from where to where, everybody? General structure is RCOONA. So carbon number, alkyl group, the carbon number varies from 15 to 17. So there is a three soaps what we are using generally. That is what, let me take C17H35. C17H35 COONA. This is the name, call it as a sodium stearate. Next, C17H33 COONA, which is actually sodium oleate, and C15H31 COONA. This is what we used to say sodium palmitate. So please remember, these are the soaps basically we have in our daily life, what we are using generally, maybe any one of these. So now you can see these soaps basically we are preparing, if you might be notice it, they're preparing by heating animal fat or plant fat, whatever it is. So we are preparing the soaps by heating what, everybody? Heating the fat, either fat of animal or a fat of a plants, whatever it is. So with the concentrated sodium hydroxide, write it everyone. Soaps are prepared by heating fat with the concentrated sodium hydroxide. What is the formula of sodium hydroxide, everybody? Sodium hydroxide or potassium hydroxide. So that is the reason we will call it as, they are the salts of what? Soaps are a salts of what? Everybody, repeat the definition. Soaps are a salts of what? Salts of? Anyone is there in meeting? Soaps are a what? Salts of? Which salt?
Long chain carboxylic acid.
Long chain. Which salt? Sodium or potassium salt? Long chain carboxylic acid or fatty acids. Please try to involve. That is what is expected. During this reaction, as well as when we are producing the soaps, heating the fat with concentrated NaOH or KOH, during this reaction, we are going to get a soap, and along with the soap, we are getting the glycerol. So that is the products. Both can be expected as the products during the reaction. So that is what you have to remember. So if you take the fat, so simple equation you learn, not required anything. So fat plus sodium hydroxide, if you have been taken sodium hydroxide. So if you undergo the heat, so we are going to get a soap is coming as well as glycerol is coming. So this is the chemical equation for manufacturing soaps. So it is not, the chemical reaction is not required for you, but the reaction of soaps is formed by the most important equation which you all studied in yesterday's class is saponification. So all of you write that one. The most important equation is this is saponification. All of you write it. The reaction of soaps formed by the hydrolysis of fats and oils with alkalis is only called it as saponification reaction. So please all of you write it. Okay, everyone, the soaps, write all of you. Soaps are formed. Soaps are formed. Soaps are formed. Soaps formation, or you write it, soaps formation by the hydrolysis of fats and oils with alkalis. That is very important. With alkalis is called, what we used to call this equation, everybody? We used to call it as Saponification reaction. Okay. So now these soaps basically what they are getting, whatever we are getting, the physical state of the soap is basically in liquid state. So that is also very important. The soaps, what is the physical state, everyone? In this reaction, whatever we are getting, it is the what state, all of you? It is the liquid state. So to make it is into a solidify, to convert into a solid, okay, to convert into solid. So what they will do means they will calculated amount of common salt is added. So to convert into solid, what we have to add it, everybody? Calculated amount of common salt. What is common salt we used to call? Anybody? Common salt means what, guys? NaCl. So the addition of more salt basically decreases the solubility of a soap. And that is why basically you can see some soaps very easily can dissolve. You can take, for example, Mysore sandal. When you are using, when you open the new soap, when it is over also, we people don't know. But Santur soap you take, even 2 months, 3 months also, still it will be existed for many boys and all you can. So that is what, that solubility is basically depends on how much amount of salt you are adding. If you take a life boy, 3 months also soap will never be over because the hardness is very, very high. So it will take more time to dissolve. The solubility of the soap is very, very less. So because of that will be depends on based upon common salt, how much you are adding for converting from which state to which state, everybody? Converting from liquid soap to the solid soap. So to convert the liquid soap into solid soap, you have to use the common salt, but common salt amount is basically increases or addition of more salt. Suppose if you take, then it will decrease as the solubility of a soap. So that is what you have to remember it. So this is all about what is the manufacturing of salts and all. So now the soap molecule, whatever you have, I want to say you that. So what is the formula of a soap, everybody? Can you tell me? What is the general formula of a soap, as I told you? Please respond. What is the general
RCO.
formula of soap? Yeah,
RCOON.
RCOONA. So in this, actually the soap molecule is made up of 2 parts. All of you write it. It is made up of 2 parts. One part is, we used to call it as a hydrophobic, and another part which we used to call it as hydrophilic. Do it, everybody. So soap molecule is made up of 2 parts. One is hydrophobic and another one is what we used to call, everyone? Hydrophilic. So now, first I'll teach you and I'll show you that. So make that RCOONA. I will write it as R. R is a what, everybody? Can you tell me? R is a what? Alkyl group. Understanding? And COONA, I will write COO minus and Na what? Na is what, guys? Na is a plus. So this Na plus, which we used to call it as a hydrophilic, note it, hydrophilic and water loving, means water soluble. Water loving or fat or dirt repelling. So sodium plus will like the fat or not like the fat, everybody? It will not like the fat. It wants to bond with the water. Now if I take COO, that is what we used to call it as a hydrophobic. And remember, the dirt which is attaching to that, it likes to attach with what, everybody? It will like to attracting, understanding, or water repelling. So now 2 important point you have to learn. So hydrophobic, will likes what? Dirt or water? Everybody. Hydrophobic likes what? Likes dirt. So it will combine with the dirt. Hydrophilic likes what? Water. So it will combine with the water. That is the conclusion you have to remember. Now, if I take as it is a long chain what we can say is long chain carboxylic group or a fat. So that long chain alkyl group, note it. This is what is the general representation. So we'll get COO minus Na plus. So if you notice it here, this is what we used to call it as hydrophilic part. Basically, we say hydrophilic part, or we can say head, or we can say polar part. So which is basically soluble in water, polar part. Now this entire one, this entire non-polar we used to call it as. So this is only we used to say hydrophobic part, and it is a long hydrocarbon chain or a tail part we can say. We can say tail part, or we can say long chain carbon chain, we used to call it as long hydrocarbon chain. So this is what we used to call it as soap structure. Now if you can see in our book also, so basically this is the picture will speak about formation of micelles. We'll discuss that. Now structure of sodium, all of your this soap, you all can see. So it will be having a two things, soap molecules, all of you observe. Hydrophilic end, this is what is the end which we used to call it as hydrophilic end, which contains what? Sodium, Na plus. And the tail part which we used to call it as a hydrophobic end. So please note it, everybody. So whatever you are seeing here, blue color, everything is a what actually? A soap molecule, a soap molecule. So everywhere the shaded region is actually hydrophilic end, and the unshaded region, a tail part, is the hydrophobic end. Now, as I said, hydrophobic end will attract dirt or water. Everybody, it will attract dirt or water. All of you. Hydrophobic end, it will attract dirt or water. Please respond. It will attract dirt or water, guys.
Dirt.
So that is what is very important. So here I think there is a small error in representation. So please, this fully it is. Here the arrow is missing. So arrow will come for R. Note it, everybody. Attracting R, this is the hydrophobic is this one, and this fully it is hydrophilic. So hydrophobic is attracting what? Dirt or water, everybody. It is water repelling. So the hydrophobic, the tail part is towards to the towards to the dirt or towards to the water. Anybody? Towards to the dirt or towards to the water? All of you. The tail part is towards to the dirt or towards the water, guys? Towards to the dirt. That is what you can see. Suppose there is an oil droplet in your hand or oil droplet in your surface. So this is what is the middle part, oil drop. Now you can see all the tail part of soap molecules are coming and attaching to it, because they will like to react with the only dirt. So that is why all the tail is showing the towards to the